Welcome back to my series on building a game engine called Midpoint. In this video, we will go over the separate file manager Tauri application. This application is necessary for syncing files such as textures, models, or landscape height maps to Auth S3 and CloudFront. In turn, we will have unique, unguessable, but public URLs of all of our files. Therefore, we will be able to use those URLs when leveraging the AI models which require them. Now, let's get started. As usual, we start with an overview of the architecture. We didn't need to use the U as the front end for this simple app, but I did anyway for consistency. We only have a few components, a context, and a single GraphQL API call on the front end. The background process contains a few of its own functions. Here we have our dependencies for the root cargo.toml file. Make sure to use the exact versions, otherwise there may be breaking changes. Likewise, we have the cargo.toml file for the background process. Alright, let's hop into the app.rs file in the front end. We have the invoke function, which will allow us to interface with the background process. We also have the app component, which we instantiate the user context and pull in the inner component. If we take a look at the user context, we will see that it is used for storing the authentication token in shared state. This is because the front end may need the token, although it's loaded and saved to a file. We define our action logic, which is relatively straightforward. Next, we have the main component, which was inside our app component. This app is still in development mode, so for confirmation purposes, we output the authentication token in the UI. We also render an authentication form if no token exists, so users can log in. Now comes the authentication form itself. It has some use statements for JSON serialization and pointer management. Also a simple struct for using the invoke function from earlier. As we begin the auth form component, we simply set our state for the form as well as set up some reusable functions for token management. Here, we manage the state for the form using typical U event handlers. Now comes the submit function for the form. As always, we enjoyed Rust verbosity, and I have also included some console logs. However, the primary functionality is just passing the form values to the API, and the API responds to the background process, ultimately also setting the token in the context. Here's the form itself for your reference. Okay, let's move to the background process main.rs file. Here you see the first Tauri command handler. It's rather simple. It just pulls the official app data path for the operating system and saves the token string to a file called Auth. While this function is not a Tauri command handler, it will be used soon. This essentially does the reverse of our handler for reading in the token string. Now we see how everything is brought together in the main function. We use Tokyo in this case, although it is only compatible on the background process, as notify requires Tokyo. Our setup is rather different, as it supplies not only the config data to the handlers, but it also starts watching the sync directory. For now, the sync directory is hard-coded. Now, Inside the watch folder function, we leverage notify and our watcher to watch the sync directory recursively every 2 seconds. What happens here is our watch directory function gets called whenever a change is detected in the sync directory. It essentially matches the event kind. For now, we are only interested in newly created files in the directory. We can handle file changes later. However, don't worry, only certain files are synced. Code and project data for the game engine is synced via separate mechanisms, such as Git and WebSockets, so we don't need to be concerned about reconciling changes. You can see that we extract the valid file paths from the event and pass that data onto our upcoming sync files function. Now we find the sync files function. It basically loops over the paths and just uploads each file with async syntax. Now we can take a look at that API call. First, we specify our structs for return data and the API call arguments. Then, we simply set up our GraphQL call as usual. On the server side, we will handle the uploading. This is necessary to protect our access keys and to update other data on the server. Next comes the API server-side code. Feel free to adapt this to a REST API as you see fit. You can see that I have an S3 class as well as the basic setup for an endpoint which accepts the arguments we specified earlier. As we continue, we find that the file path can be dissected to provide valuable information to this endpoint. We also create the file key, which will be the S3 path for the S3 object. Here we simply specify some additional details and use the S3 class to actually upload the asset. Now, here I feature Prisma, which is my preferred TypeScript ORM. Of course, any ORM will do. We are storing the saved context from the game engine application in a JSON Postgres field. This is how we sync project data in real time. An empty context is instantiated here in case one does not exist on the project we're uploading to. Now, since we're uploading concepts currently, I will only show that code. However, all of the code is available on GitHub. We basically add in the newly uploaded file into the correct area of the context using its newly retrieved CloudFront URL and other relevant information such as the local file path. Here's how we connect some dots with a previous video. In a previous video, we set up a WebSocket handler for refresh context in the game engine. This is the spot where we actually broadcast that command to those in the project group. Let's check out the actual WebSocket setup inside the index.ts file, although you can put it where you wish. We handle groupings ourselves with a simple record type and set type. The broadcast function leverages this simple grouping system to send messages to the relevant clients. I also want to show the connection event, as this is where the JWT gets validated for the WebSockets. The JWT package is employed here to verify the token signature, and ultimately the current user data is passed to each WebSocket handler just like with API endpoints. Now, to finish up this video, let's check out the S3 class. You can see that I instantiate the S3 client using my environment variables provided by a .env file. We also specify a couple helper functions which make storage easier. Inside the upload asset function which we used earlier, you will see that we first calculate the size and assure that it's within reason. Then, similar to our Rust setup from another video, we will need to assure that any file uploaded is cleaned and made unique, so it is unguessable and won't create future bugs. To wrap up this function, we clean the base64 data supplied to the function. Then we leverage the S3 client to upload the file data to the correct location. There we go. That's an overview of the File Manager app for your game engine, Midpoint. Now, we can collaborate and generate models from concepts. If you liked the video or learned anything, be sure to subscribe. Thank you.